Okay, so this question asks, how much heat is released when 12.5 grams of C2H6O burns? And then you're given a chemical equation for the combustion of C2H6O, reacting with oxygen to produce CO2 and water, and it's already balanced for you, so that's nice. And then over here, you'll notice that it gives you the delta H for this equation, and delta H equals negative 1,368 kilojoules. Remember that since this is negative, that means that energy is leaving the system. So this is an exothermic reaction, which makes sense because this is a combustion reaction, and whenever you think of combustion reactions, they usually release energy. Now, it tells us that we have 12.5 grams of C2H6O combusting. According to the coefficients here, since there's an imaginary 1 out front, for every 1 mole of C2H6O that combusts, it releases 1,368 kilojoules. Well, we don't know how many moles of C2H6O we have, but we do know how many grams of it we have. So we should be able to go from grams of C2H6O and convert that to mole of C2H6O using its molar mass. And then since we know for every 1 mole of C2H6O we produce 1,368 kilojoules of energy, we should then be able to convert this to kilojoules. Okay, so we'll start our dimensional analysis. We have 12.5 grams of C2H6O. And we want to get rid of grams, so we'll put that on bottom. We don't want grams of C2H6O. We're trying to convert that to moles of C2H6O. So we've got mole and grams, so that's the molar mass. 1 mole of this. Add these numbers up, and you get 1 mole equals 46.068 grams. That will cancel out my grams of C2H6O. However, we have to keep going because we need to convert to heat, which is right here. Now, according to this, again, there's an imaginary 1 here. So for every 1 mole of C2H6O that reacts, it will release 1,368 kilojoules. Okay, so we want to put mole of C2H6O on the bottom to cancel, kilojoules on top, and we said for every 1 mole, imaginary 1, for every 1 mole of C2H6O, we're going to release 1,368 kilojoules. That will cancel out our mole of C2H6O, so now we just have to multiply across the top, divide across the bottom, and that should tell us our answer. So let's see what we get. And we'll just round it off. It turns out that when you combust 12.5 grams of C2H6O, you will produce 371, and that's a negative because it's being released, negative 371 kilojoules of energy.